Okay, now from the previous video, we have conditional expectation of xt given f sub s. And we computed this equals to bs squared minus s. Obviously, bs squared minus s is very different. It's very different from x sub s, which is b1 bs minus s. So see, this is the conditional expectation of x sub t given fs. And if you look at this form, it's very different from x sub s. Of course, this is not really total surprise because we know this stochastic process xt is not adapted. It's not martingale. But let's put this as equation 1. If we stop here, then we don't discover new things. But being a mathematician, we always want to go further as far as we can. So now I do this. I observe this. Put t equal to s to get put t equals to s in equation 1 to get this equality x sub s. You see, we put t here equal to s, fs. And that is bs squared minus s. You see, x sub s is not x sub t is not adapted, so x sub s in general is not f sub s measurable. But the conditional expectation of x sub s given f sub s is b squared minus s. And I put this as equation 2. Now equation 1 and 2 imply the following. You see, in equation 1 and equation 2, the right-hand sides are the same. So this implies this inequality. Conditional expectation of x sub t given f sub s equals conditional expectation of x sub s given f sub s. And this is for s less than or equal to t. And of course, almost surely. So we have this equality. And now observe that this equality becomes a property. This equality becomes a property. And we have this concrete stochastic process xt, and this in our discussion that this stochastic process xt satisfying this equality. And of course, nature question is, are there other stochastic processes that satisfy this quality? And soon we discover there are many of them. So this is a property. Now, in particular, observe this. Suppose the stochastic process, suppose a stochastic process xt is a martingale. Then the right-hand side, because x sub t is is adapted, so the right-hand side is the same as x sub s, almost surely. And then this property reduces to the martingale property. So this equality is something weaker than being a martingale. And we'll make an abstract concept of this equality. So here we have a situation which I emphasized several times. A simple example. This to a new concept. And this is a perfect example of this idea. And so we are going to make this definition. A stochastic process x sub t, or t between a and b, is called a, we are going to give a name for this property. It's called a something with respect to a filtration f sub t. If the expectation of x sub t observation is finite, so that we can talk about the condition expectation for all t. And the condition expectation of x sub t given f sub s equals condition expectation of x sub s given f sub s, almost surely, for all s less than or equal to t. So what is the name? What is a good name for this? You see, suppose x sub t, the stochastic process xt, is adapted with respect to the filtration ft. Then x sub t is a martingale. And now, since in general x sub t in our new theory of stochastic integration may not be adapted, and therefore a good name for this is called, namely, it is not so far away from being a martingale. If x sub t satisfies this and x sub t is adapted, then it is martingale. So namely, this concept is more general than martingale, but it's not so far away from being a martingale. So I call this a near martingale. That is the name that I gave when I discovered this property some years ago. It's called a near martingale. Okay, let's go to the next page. This is page 33. Okay, remark. In the martingale theory, we have martingale, submartingale, and supermartingale. And we can introduce the same similar concept. Near submartingale. And the definition is the condition expectation of x of t given f sub s is greater than or equal to the condition expectation of x sub s given f sub s. So this is for s less than t. So the condition expectation of the future is greater, given the information at the present time, is greater than or equal to the condition expectation of the present time given the information up to the present times. And near super martingale, the inequality is reversed. Condition expectation, this is like in gambling house, okay. X sub t given script f sub s is less than or equal to that. Okay, let's work out the several examples. The first example 1. Consider the following stochastic process. X sub t equals to the integral from 0 to t of b1 dbs for t greater than or equal to 0. Now this time we look at this t greater than or equal to 0. The first case 1. when t is between 0 and 1, xt is, we know, it is b1 bt minus t. Case 2, when t is greater than 1. When t is greater than 1, xt equals to the integral from 0 to 1 plus the integral from 1. Okay, let's see. b1 dbs plus 1 to t b1 dbs. And the first integral is just put t equals 1 here. It is b1 minus 1, b1 squared minus 1, plus, and now for the second integral, t is greater than 1, and so b1, the integrand is adopted for the integral from 1 to t. So this is an Ito integral. And so we can pull b1 out, and then bt minus b1. And that equals to, now b1 squared and b1 times b1 squared is b1 squared minus, so that cancels out. And so this is b1 bt minus 1. Therefore, we have x sub t equals b1 bt minus t, this is for t between 0 and 1, and is b1 times bt, the same here, then minus 1. It stopped at 1. Okay, so we stop here for this video, and we'll go to the next video.